Okay, y'all, I just figured out how to make my document camera taller so I can actually show a whole page because I've been fighting with trying to keep the paper in and out of the page, as you've seen. And oops, I had no idea. So here we go. Now we can actually see the whole page. So hopefully this will be easier for you all. So again, we're looking at exam number 2, fall 2014, strengths exam. This is in your review module. Problem number 1. So we have 3 rigid plates that are connected together with 6 identical aluminum dowels. Determine the required diameter for the dowels to the closest eighth of an inch if the allowable shear stress of the dowels is 1/2 of the yield shear strength of the aluminum. Okay, 1/2 the yield strength of the aluminum. So this one is pretty cut and dry. It is not asking us about yielding of the plates this time. Sometimes it does, sometimes it doesn't. So I have 6 dowel rods. I can see if I'm coming from the left, I'm going to have double shear, top and bottom. If I'm coming from the right, it's going to be a single shear situation. So they're connected with 6 identical aluminum dowel rods. So I need to go back to my sheet, my first sheet, and I need to pull probably that my E is 10,600 KSI, except that I just messed up, didn't I? I just messed up. What are we in? What are we looking at? If we're looking at the dowel rods, what are we looking at? We are actually looking at shear, which is G, and shear, which are those values. So you have to make sure that you're pulling the correct values or it's just flat out wrong. And then my yield is 25 KSI. So I have 3 rigid plates are connected with 6 identical dowel rods. So I'm going to just come from this side. If I come from the right, then I know that P over 2 is 75 kips divided by 2. And when I'm looking at my dowel rods, there is going to be a shear force that's coming across this plane. Okay, so if I sum forces in the y direction, in the x direction, they have to equal 0. So my shear, my total shear equals 75 kips divided by 2, which is 37.5 kips. Okay, and shear stress, okay, shear stress equals V over A. When I'm looking at this, again, if I was coming from the left and using 75 kips, I would have to use double 2 shear areas because I'm just looking at this single shear with half the load. I'm only going to be in single shear, but I do have 6 dowel rods that will provide that cross-sectional area. It also says that the shear stress is 1/2 of the yield shear strength. So if the yield shear strength is 25 KSI, then my allowable, I have to put that factor of safety in, is 25 KSI divided by 2. So my allowable shear stress is 12.5 KSI. So that's, oh my gosh. Oh my gosh. Oh my gosh. We're looking at shear. Okay, we're looking at shear. So I have that value, I have that value, and then I have to know that area is pi over 4d squared. And it says required diameter. So 12.5 KSI equals 37.5 kips divided by pi over 4 d squared, and I have 6 of those dowel rods. When I do my math, I'm going to get that the minimum it can be, the required that I need is 0.7979 inches, but I need it to be to the closest eighth of an inch. So that looks like it's bigger than a ½ inch. So what I do is well, I could have a 4/8 of an inch, which is 0.5. I could have 5/8 of an inch. I could have 6/8 of an inch. I could have 7/8 of an inch. This is 0.75. I can see that we're bigger than 0.75, so let's make sure we're smaller than that 7/8 of an inch. So let's go back. I have 7 divided by 8 equals 0.875 inches. And lo and behold, this is larger than a 6/8 inch diameter. It is smaller than 7/8, but if I have to round to the next largest, I'm going to round to that I need a diameter of 7/8 of an inch. And there's my answer.